Otherwise, morning. Kristen, I can't hear you. Yes, yeah, I can't really hear anything from you. Maybe you can try checking on the mic a bit. Emma, for you, I think you can be able to get me. Yeah, as a Christian is trying to reconnect, maybe you can be getting in the chat, giving us what we did look at last time, possibly. What we looked at or what we learned last time. In summary, what was that we learned with the lenses or learned about lenses? Types of lenses, correct? Another? Christian, I hope you can now be able to get, you are now getting me clear. Power of a lens, correct? Power of a lens, that is true. Then some concept on center of curvature, how we had to define that out, and, that was true. Another additional thing that we did look at? And be able to read from the chat or the new audio. I don't know if you're really getting me, but I think Emma is okay. Emma is giving me a lot here. Good. Now that I think you have connected well. That's what Peter can remember. Yes. Christian, what do you remember from all that we learned last time? You can unmute your audio and speak. You also prefer to go in the chat. The different types of lenses, convex lens. Another. Good. Concave lenses. What is the other name of convex lens? What is the other name of convex lens? What effect does convex lens have on light after refraction? What does it converge light rays or it diverges light rays? Amira, you're most welcome. I hope your audio is okay. I mean, your microphone is okay.
Yes.
Good. Saying convex lens converges the incident rays towards the principal axis. It converges the incident rays through, but to pass through the principal axis. Correct. Observation. What about convex? That is convex. That is a convex lens which converges. What about concave? What about concave? Christian? I see you've given a text here. Concave is divergent lens. How does it? What effect does it have on light rays after refraction? It spreads out light rays that have been refracted through it. So on a refraction, light rays appear to be coming from the near principal focus. Very good. Now today, we are going to move on to, hope you're welcome for this lesson. I think you've just joined us. Hopefully your audio is okay. Can you confirm that your audio is okay? And then you'll be able to contribute. Yes, it is. Yeah. I think those of you who got me from the WhatsApp group, I was able to say that you should be able to attend this lesson while maybe you have possibly the mathematical set and then a graph book or a graph paper or even graph papers, because what we're going to is are you all having graph papers? Amira, Hope, Christian, and Peter?
Yes, I have.
Christian is having. Hope is said. Hope is also having. Peter, good. Amira.
Yes, I have.
Okay. Now let's move straight to what we're going to look at. So this is a practical thing. We're going to look at ray diagram, construction of ray diagrams. So when we talk about ray diagrams in physics, we are meaning diagrams which are used to locate or describe the images formed by a given optical system. Ray diagrams are diagrams which are used what? To describe and locate image formed by a given optical system. So the given optical system may be lenses, or it may be as a result of our case mirrors. But this time we're looking at the one of lenses. So the paths of light rays in such diagrams are represented by straight lines. So we're going to have straight lines like this. I hope what I'm trying to draw on my my whiteboard is straight.
It's good, sir.
So for you, you're going to be using the rulers. Make use of the rulers. Straight line like this with an arrow. This shows the path of a light ray. It shows that the light is from the direction of left to the right. So we are going to represent light rays in such diagrams like this with the straight lines with an arrow, which shows the direction of movement of the light. Now there are certain properties that we actually will be looking at, we're interested in looking at as we are going to have the construction of ray diagrams. But these properties that we're going to look at are, one, what type of image is it? Is it a real image? What type of image is it? Is it, one, a real image, or it is a virtual image? Is it a real image or it is a virtual image? I know from the concept of mirrors. Many of you might have known what real images are, what virtual images are. So what are real images? Can we differentiate between the two? As we shall straight away move to this principal rays, because construction of ray diagrams are governed, or we are guided in that by the principle or the standard rays. We shall look at these standard rays, and then as we are going to do it practically, you will be doing it there. But later on, I will expect you to submit your work. You will probably take me, you'll use the camera of a phone. Then you try to take this, you get using the camera of the phone, you'll be able to share for me what you have done, possibly after our lesson. Is that okay? Is that okay with everyone?
Yes, sir.
Yes.
Good. So we are looking at now the properties. We need to understand. One, an image might be real or it might be virtual. Two, an image might be upright. An image might be upright, which sometimes we say what? Erect, or it is inverted. When we say it is inverted, what does it mean? Upside down, okay? Then an image might be magnified, or an image must be diminished. I hope you're all seeing clearly what my screen is trying to give you.
Yes, sir.
Good. Now, if we can be able to come to this, let's start with this. Can we differentiate between real image and virtual image? We should not be wasting a lot of time here, because this is more of like some guidance. We have good work to do. This is just a reminder. You know, when you are looking at it, mirrors, curved mirrors, you already had known this. What is a real image? Anyone? Christian, can you try? Emma. Christian, you read for, hope you read what Emma already has for us from the chat.
A real image is the collection of focus points actually made by converging rays, while a virtual image is a collection of focus points made by extensions of diverging rays.
Very good. Very good. Very good for that contribution, Peter. So we're saying the images are real in a simple, we can just say a real image is the one that is by the convergence of actual rays. Real image is the one which is formed. Divine is trying to give us some other answer there, I think, which is also correct. A real image is the one that is formed on a screen by the convergence of actual rays. Or in short, we always say a real image is the one which is formed by the convergence of actual or by intersection of actual rays. In short, when an image is formed as a result of intersection by actual rays, we shall be saying that the image is real. Now, if an image is formed by intersection of imaginary rays, we shall say that is what? Virtual. I think that is in simple what I can say. Next, I want us, but you will find that in image formation, an image cannot be both real and virtual. Is that okay? An image may only be real or it can be virtual, but not both. When you write both answers in a question as an answer, you are going to be crossed very well. Even both will now be crossed because you're trying to confuse an answer for an image. I mean, an image may either be a virtual or real. It can't be both. So you have to make selection on one. And also similar here, an image may be upright. Upright is when we say it is erect. The head remains up. Jackie, you're welcome for this lesson. We're moving on well. So far, we're at another level, but I think you're not bad off. An image can be upright, which we say is erect, or an image can be inverted. Inverted is when it is upside down. I hope that is clear. And similarly, an image cannot be both upright and inverted. It has to be also one, either upright or it has to be inverted. Lastly, magnified. When do we say an image is magnified?
When it's
Jackie?
made bigger.
And then Hope, when do we say an image is diminished?
When it's smaller.
When relatively it is smaller than the object. You look at the object, if the image appears to be bigger than the object, we say it is magnified. When it is smaller than the object, we say it is diminished. Good. Now, I want us to look at the principal rays. All of you can be muting. You can mute yourselves. Mute yourselves. Let us be mute. Hope you mute your audio. Hope you mute your audio. Good. Yeah. So let us now move to what was supposed to be, what I said was what we now have to look at. We're going to look at now the principal rays. Before we construct a ray diagram, you need to know about the principal rays or the standard rays. Now, what are these standard rays? There are three of these standard rays. The first standard ray is a ray that passes through a ray that passes parallel to the principal axis. But actually, maybe before we can look at it, we needed to remind ourselves of how we can be able to, on a ray diagram, represent a converging lens and a diverging lens. Our convex lens, which is a converging lens on a ray diagram, is represented by a line like that, just a point with an arrow on both sides. Have you seen what I've tried to present there? Are we there?
Yes. Yes.
Then this line is called
Principal.
This line is called principal axis. And then this is now our, what I'm pointing, trying to show using the red arrow is what is now our convex lens.
Convex lens.
That is our convex lens. So that's how we can be able to represent the convex lens. Or else, even on a ray, we can be able to represent convex lens on a ray diagram like this. Is that okay?
Yes.
So there are two. It is either this or it is this one. So it is now your choice. It is you to make the choice. But actually, this is in most cases the one that we commonly do have. But when you're presenting using the second one, which is this, make sure that that one there, the size of the convex lens that you've represented is what? It's a bit, it is what? Small, okay? It should not be very big.
Yes.
It should not be very big, it should be small. So that is what I want us to. There are three principles. I mean, that is for convex lens. For converging lens, I
There's
mean for
three.
diverging lens, concave. For concave lens, we have this. Also very small. We can have just something there on the top like that. Is that okay? That shows it is a concave lens, which is what? Diverging lens. Concave lens is called a diverging lens because it diverges light rays. Or we can have it, or we can have it like this. We can have it like this. But all these lines that I'm drawing, for you must be doing, when we're going to look at this, you must be doing using what? You must be doing using, see, a simple like that. That is the symbol of diverging lens. Are we all good to go with that?
Yes.
I think you now all know how we can be able to represent converging lens and
And
diverging lens,
diverging lens.
which converging lens is a convex lens, diverging lens is concave lens on a ray diagram. Now, these ray diagrams in the construction follow the principal rays. So it follows what we call the principal rays. There are three principal rays. There are three principal rays, or we have three what we call standard rays. These principal rays are also referred to as standard rays. They are rays that enable us to come with our ray diagram. They enable us to come up with a ray diagram. And then we said in the ray diagram, we shall be able to locate and describe, locate the position of an image and describe the nature of the image, how the image appears. Is it smaller than the object, which we say diminished? Is it a virtual, or that is it a rect? So those are now the what? Describing the nature of the image. The position is going to be, is it beyond the principal focus or what? That is what we're going to look at. Then let's move to this principal rays. The first principal ray is there anyone who has a knowledge of it? Because it is all there in our, those who will have gone to the site and read through might have got the concept or might have got it, because I remember directing you there the other time. Anyone who knows the first principal ray or the first standard ray? If I have this, and then I have as well, I have this. I'm saying this is what? For my case, I'm starting with what type of lens is this?
Convex.
Even that. This is the first principle. Christian has written for us something there, has given for us the first principle. I'm saying Hope should be reading for us. If Hope cannot be reading, Jackie, you read.
Okay. The ray that is going into the lens parallel to the optical axis, this ray gets bent to go through the focal point. And that is the first principle.
We have a ray like, I mean, that is correct. He has given for us the correct answer there. That is the first principal ray. So we have, see, we have this. At this point, I might be having F. Then at this point, I have my twice, you can say F. Maybe I have also there F. I have that side there. twice f. Now we are going to see this. Maybe let me use different ink so that it doesn't confuse us. This is what? Where I have the arrow. What is that? What is this?
Concave lens.
Concave?
Convex.
Convex lens, correct?
Convex lens.
Convex lens. Now what do you call this line?
The principal axis.
Principal axis.
Principal axis, correct. What do you have called this point where you see the red mark and the arrow is directed to?
Optical center.
What is
Optical center.
correct. Good. So you see, these are the points where we're going to be making our references from. We are saying the first ray is, and they were saying this is what the principal, the first principal ray, and then it is for the converging lens, which is the convex lens, which has a ray parallel and close to the principal axis, so that it is a ray. We shall have to indicate that arrow. What I'm doing here, you now have to use your ruler for doing it. Is that okay? By the for me, I'm doing mine using a free hand because I can't be placing a ruler here, I think, on my screen and draw this. Are you getting my point?
Yes, teacher.
But for you have to use a roller. A ray parallel and close to the principal axis, only refraction passes through. I think it is not getting at least that. Are you seeing this?
Yes.
A ray which is close and parallel to the principal axis, only refraction passes through the principal focus or the focal point. And then we say that a lens has two refracting surfaces. This is the first refracting, this is the first, Christian is asking, should we draw that? I will tell you to move on it. I will tell you what to do later. You first get it.
Okay.
You'll get to draw it. Allow you first look at what I'm doing, and then you just see and follow the instruction. You'll do it late after this. I'll give you the time. You see, a lens has two refracting surfaces. The first refracting surface is the one which is where you see I've put the yellow mark. Okay, this is to the left. Then we have one which is to the right. There are two refracting surfaces because they're two curved surfaces. So because of this, we shall be saying that this one to the left is what we call the near focal point. This focal point is called the near focal point. The one to the left is the near focal point. The one to the right is the far focal point. So we shall say a ray which is close and parallel to the near principal focal, which is close and parallel to the principal axis, on a refraction passes through the far principal focus. That is the first principal ray for a converging lens. But for a diverging lens, this ray appears to be coming from, let us see the case for a let us have the case for this, which I said that is the simple for we can have this is F, this is twice F, then similarly there we have F, this is also twice F. A ray which is close and parallel, let me change this color, can be having here green, a ray which is close and parallel to the principal axis on refraction appears to be coming from this. Yeah, I hope you can be seeing my screen now. Are you seeing that ray diagram?
Yes.
Yes.
A ray which is
Yes.
sure about that internet. Someone is trying to comply. I think Peter is having some poor internet connectivity. We're saying a ray which is close. There are two. I want us to be seen. Let me clear this. Let me also clear this. Let me go to and we clear this. I want to be showing all those diagrams there. Let me clear this. Then we come to this. I think we can be able to see. I think we can be able to see that from here. We can see that that
Would you guys
noise from
stop
the
that?
background. Could you just mute, please? Which is close and parallel to the principal axis. See, on refraction passes through the far principal focus for converging lens. Meanwhile, for a diverging lens, it appears to be coming from the near principal focus. Yeah, Peter, what we are saying is on the first principal ray, we're saying a ray which is close and parallel to the principal axis. On a refraction, Peter, I hope you can get me now. What we are saying is a ray which is parallel to the principal axis on a refraction by the lens will pass through the principal focus on a refraction, or it appears to be coming principal focus for divergent lens. So that is how far we have gone with the first principal ray. So that is the first principal ray. Are we all good with that?
Yes.
Yes.
But remember that from here, the distance between the optical center, all of you now know where the optical center is. Those ones who are trying to have a conversation with someone who's in your background there, please, you try to pay attention here. I think I may not be able to go up to there, but you just have to concentrate here. This is a very critical point where you need to participate. I mean, you need to have full attention here. So you can see that whatever I emphasize here is going to be very important. When you miss it, you'll miss it all. So you can see the distance between the optical center, the distance between the optical center and the principal focus is equal to the distance between F and the twice F. Is that okay?
Pardon?
So I'm saying you in your construction, when you're going to have the construction, make sure that the distance between F and the twice F is also equal to the distance between what? If I can say this is O, if I can say this is O, where O is what? The optical center. Is that okay?
Yes.
What I'm saying is the distance we can say from O to F, the distance is equal to from F to twice from F to twice F. Clear? Distance from where O is the optical center, F is the principal focus. If distance O to F, if the distance here is, maybe if this distance is 2 centimeters, that distance must also be what? 2 centimeters. Is that okay?
Yes, teacher.
At the end of it
No.
all, the distance from O to now twice F, this distance will be 4 centimeters. Someone just said, no, I'm repeating for that person, but now on the diagram, I'm just saying that I'm now using the red ink to illustrate this, okay?
Yes.
Are you seeing what I have?
Yes.
That distance with the red is actually equal to the distance also from here up to this point. Is that okay?
Mm.
And this is the same for that side. It is the same thing for the right-hand side. Then at the end, we now know if this is, we're saying if this is 2 centimeters, and then this is 2 centimeters, which means now the distance from here up to there is what? 4
centimeters.
centimeters. So yes, it is a must. It is a must that Christian is just asking. It is a must that the distance must be equal. If it is not equal, your ray diagram is going to be inaccurate. Is that okay? Your
Yes.
answers you're going to get are not going to be the correct answers. So at the end, you might be missing on the mark. So the distance of the image might not be the one which is required. The distance of the object might not be the one which is required. That is the first principle ray. So let us move to the second one. The second principle ray is, we now know some of these terminologies. I will have to move on, increase my speed a bit. Now for the second one, we're saying a ray which is a ray that passes through the principal axis. I mean principal focus. A ray that passes through the principal focus of a converging lens on a refraction. A ray that passes through the principal focus of a converging lens like that. Let me use green. Let me use green ink here to draw the ray. A ray that passes through. Why? A ray that passes through like this. Are you seeing that? A ray that passes through the principal axis on principal focus on refraction in a converging lens will be refracted parallel to the principal axis. Is that okay?
Yes, teacher.
Yes, a ray that passes through the principal focus will be refracted parallel to the principal axis. So that is what happens with the second principal ray. So we're saying a ray that passes through the near focal point or the principal focus of a converging lens, or that which appears to pass through the far. For now, the principal, I mean for the other one, it is a different case. For, we can say now for this one, for our divergent lens, this principal focus maybe is there. This one is twice F, this is F, and then this is twice F. I'd said for now, this one, a ray that is to pass through the far principal focus. See, now like this, we imagine a ray is to pass through the far principal focus like that. This ray is going to be refracted parallel. to the principal axis. Are you seeing the situation here for the diverging or concave lens? We're saying a ray that is to pass through the far principal focus of a diverging lens after refraction will pass parallel to the principal axis. Meanwhile, we say for that one for for this one, we shall say a ray which passes through the principal focus on refraction will be parallel to the principal axis for a converging lens. So this is the second principal ray. Is that okay?
Teacher, come again.
I'm saying the second principal ray is that for a converging lens, a ray which is what? Parallel. I mean a ray which passes through the near principal focus on the refraction passes parallel to the principal axis. It is actually the opposite of the first principal ray. The first principal ray is that. Let me get my red. For the first principal ray, it was like that, a ray which is parallel. See, on the refraction passes through this. You see, for the first principal ray, it was what I've indicated with the red. Is that okay?
Yes.
Now, for the second principal ray, it is the opposite. When the ray simply changes direction. From the law of reversibility of light, I think principle of reversibility of light, when the direction of light is changed, it passes through the same point. That is from the principle of reversibility of light. So here, that is what we can be able to obtain from here. Then similarly, also what we have for the other one there, you can see that if we're to force away here, we are to from this here, if we're to this ray, it is meant to pass through the far principal focus, but it gets refracted here because from the first principal ray we said that a ray which is parallel to the principal axis on the refraction appears to be coming from this. You see it? Is that okay? We have simply reversed what? The first principal ray. So the first principal ray has been reversed in order to get the second one. And then the third principal ray is the simplest. Third principal ray is the simplest. So the third principal ray is, it is just for all. Here it doesn't matter. Whether it is, I don't want to use red in this case here. Let me use black. Whether here it is a converging lens or it is a diverging lens, for this, we're saying a ray that passes through the the optical center, the ray passes undiverted before and after. Before refraction and after refraction, it remains. So a ray that leaves the object through the optical center passes the lens without being deviated. This is both for, if this is what? It is the same case if we had here, what I'm indicating with the red is what? Diverging lens. What I've indicated with the black is the converging lens. Diverging lens is with the red, converging lens is with the black. Whether it's a converging lens or diverging lens, any ray that passes through this optical center, of course, we said the optical center is what I've marked with the blue here. It is what I've marked with blue here. A ray that passes through the optical center remains undiverted, and I mean undeviated after refraction by the lens. Is that okay?
Yes. Yes.
So those are now the principal rays. Now, when you're going to find out, when you're going to determine the position, are we good to go with that? Now from here, I'm able to locate image, be able to draw ray diagrams following those rules. If someone has a problem, you can just log on to the site and then you check there. Those ones will be able to guide you further. And then learning is a process. See, you'll continue to move on. Yeah, I've loved the comment of Christian. I think so. Yeah, it's been all about positive when we can be able to achieve. Yeah, if all is negative, it's very hard. Be positive, think positively. Say, yes, I can be able to do this. Yes, I am going to do it. The worst should be saying, I can try. And you should be die trying. I think that's the energy I love. Yeah. So now I want to give an example. If we are now moving to, I want just maybe, do I still have some free space to have a whiteboard? Yes. So maybe for ray diagrams for locating convex lenses, the properties or the characteristics of the image produced depend on the position of the object. The object may be between the optical center and the principal focus. See, I was saying this is the optical, this may be the principal focus. This is twice F. So let me use now red here. So the object may be here. Are we seeing my screen? Are we seeing my screen?
Yes, teacher.
Good. So the object can be in between the principal focus and the optical center at any position here, or the object can be in between the F and twice F, or the object can be exactly on F, or the object can be on twice F, or even the object can be beyond the twice F. Then from there, you will determine different properties of the images and then the different types of, different object, image. The nature of the image will be basically depending on where the object is here. Maybe now what I can say is, for example, if the object is here, how do you represent the object? Usually the object is represented by a solid line. We can represent an object here by a solid line like that with an arrow on it like this. Are you seeing my red object,
Yeah.
red thing there? So that can be the object. So an object is represented by that. Now after this, if we wanted to draw the ray diagram, we can now be following, from this, we can now be following the rays, the principal rays. Can be following the principal rays. Can be following the principal rays. So a ray, the first one, we can say a ray parallel to the principal axis on a refraction passes through this. Are you seeing that? I'm just having a very poor sketch though, but I think when you are going to use a roller, it will be very fine. This ray should really be from the head of the object. Is it okay? We're now using the principal rays, but for determining this, you only need what? You only need two principal rays. We can take this with the other ray that passes through the optical, ray that passes through the what? The optical center passes undiverted, and see, we can continue to draw this and then that. Then you realize that as you move towards the other side, if you'll be to the scale, you can see that here what? Towards here, the rays are what? They are getting diverged. So which means we needed to extend. So the rays backwards, we needed to extend the rays backwards like this. Because these are now imaginary rays, we shall be using dotted lines. Is that okay? Behind here, it is now imagined that you use dotted lines here. So similar there. So you'll find there's going to be a point where I want to say somewhere behind this way, behind there. Are you seeing where my blue is? The blue mark with a lot of lines drawn there. That is possibly going to be where the image is formed. And now, because the image is formed this side, when the image is formed this side, which I said the image is formed behind. So the image is going to be what? Virtual. And then virtual images are drawn with dotted lines. I think for this, we can be meeting next time. Is that okay? Can we meet for this next time? So that we now move on to have the ray diagrams in the convex lenses and depending on the position. Christian is Christian saying okay. Christian saying okay. Another person? I don't want to be dictating upon because we need to just move on by consensus. Amira, are you okay with that? Are you okay with that? Amira is not part of us, I think. Hope?
Yeah, it's fine.
Good. Jackie?
Yes, teacher. I'm okay.
Good. So now the assignment is, can I have the assignment? Can I read for you people the assignment? I'm not going. What you're going to do? I tried to next time. Jackie is saying try to understand by next time. But yeah, obviously that's how we learn. Learn through a process and get on slowly. With the support from what you have from the site, I want you to draw for me the three principal rays. Draw for me the three principal rays. Stating in each case for a convergent lens. Let me type on a whiteboard. Sketch the principal, the three principal rays for a convergent lens. Converging lens, stating them and stating them with the distance between optical center equals to 2 centimeters. Are you seeing that?
Yes, teacher.
So you can write that, sketch the three principal rays for a converging lens, and you state the three principal rays as well. I mean, you stated how they are stated. You stated the principal rays. You sketch you sketch them. You have a ray diagram showing them, and then in each case you have to state, and then the distance from the optical center to each of the principal foci must be, because a lens has got two principal foci, which means one on both sides. I mean, one on both sides of the lens. So we have one to the left, one to the right. From the left to the right, we shall have 2 centimeters. Then if you want to take the distance to 2 centimeters, I want you to come up with simple sketches. Maybe if there's a point that specifically you don't understand, I think, yeah, you can still be arranging for another. I mean, you can settle at your own free time, as long as I think this engagement at this time I'm settling because I want all of you have to be. But you can settle one where we can even meet any time at our convenience with you. Yeah, you can include twice F. Include twice F as well. Someone is asking, can we include twice? You can include it. Then from there, you do those 3 principal ways. Specifically, I'm going to look at how nice your diagram is going to be, how neat it is. So after doing it, you use the camera, you take and can send my personal email, or if you don't send the personal email, you can even send personally to my WhatsApp account, not to the group one, so that I also respond privately there to yours.
Excuse me, teacher, could you send me your email?
Just sketches are not accurate diagrams. The sketches are going to be obviously accurate. The sketches are accurate. The sketch is always, sketches must be actually. Why I'm saying it is, why I'm using the word sketch here is, we're trying to imagine a situation, not the reality. I'm trying, because I want to test how far you've gone with this concept. So that's why I'm saying a sketch. So you have to come that, but it must be accurate. The sketch must be accurate. We have the accurate sketch where you have to use the rollers and so on. I think all of you have written the question. I think I can I stop there and then, yeah, it's okay.
Yes, teacher. Teacher, excuse me. Teacher, can
yeah,
I have your? Excuse me.
I'm giving my someone.
Teacher, can I have your email address, please?
Question for my email.
Yeah.
There it is. I think you have got it.
Yeah, thank you.
You're welcome. Thanks for the participation. Let's meet another day. Have a very good afternoon. Have a very good morning.